everybody, me and Mr. Sansoni here. We're going to just kind of go through what the scientific method is. Any ideas what the scientific method is?
No clue.
Nothing, huh?
No idea.
Not even a shot. Not even a shot in the dark. So, well, let me help you out. Okay, so scientific method is something we use when we are trying to figure out some scientific problems, for example. Okay, like me and you both science teachers, so we're going to use that to go through the scientific method. Okay, a lot of scientists use this because this is how they investigate the world. All right, so a lot of their investigations are done because they're like pondering, they see something happen, and they question it. Okay, so far so good?
So we ask questions.
We ask questions, and then we use this scientific method to solve it, basically get an answer to the question.
What's that word mean?
Which one?
Inquiry.
Inquiry, like wondering, questioning. We want to know about something. Make sense? Pretty good?
Sounds good.
All right, so let's take a look. Okay, so the scientific method, this is what we use, or the steps. Kind of like...
Steps like going upstairs when I'm going to bed?
Well, I guess similar if you're trying to get to your bed to go to sleep, but steps like in instructions.
Ah,
so,
okay.
like, say you buy
like IKEA.
Yes.
I know those.
Those are probably the worst instructions ever. I feel like I never put things together correctly. But, so like your steps on how to build your new cabinet. Okay? So we could use the scientific method to do the same thing. But this is more for science stuff. Okay?
Got it.
All right.
Science. I think I should know something
Something,
about science.
just a few
Maybe.
things?
I'm not
okay.
sure.
All right, so here's our steps. We got number one, we got to state the question or the problem. And before we can even do the stating the question or the problem, we typically make an observation. Do you know what an observation is?
Yeah. I see things.
Right, perfect. All right, observing, right? Okay, then we make a hypothesis or a prediction. So basically we see something, we ask a question like, oh, well, this must be the answer. Or we basically make a guess, okay? And then we do an experiment, and in our experiment we have our materials, which are things that we need to run this experiment, and a procedure. So there's our steps again on how it's going to work. Like step 1, take the board out of the IKEA box. Step 2, insert screw into hole. Those types of things.
Got it.
Okay? Then there's the results, and then your conclusion. So your results is like your data collection, all the numbers you gathered, and then your conclusion is looking at your data to see if your hypothesis was correct. Okay?
Sounds good.
All right. So first one, state the problem or the question. This is the stuff that it's like, what do I want to know? So I got a good example here. Okay? So of course everyone's favorite subject in school is lunch, right?
Absolutely.
I mean, everyone loves the time. Everyone loves the time to sit there and just relax and not think about work. Okay? So the example we're going to use is, what do I want to know? Well, getting to lunch in enough time to utilize the whole period. Like, how can I get there the fastest way without teleporting? Because that's not a real thing. I don't know if you know that.
It's not.
No, it's not.
Isn't that what we've been working on for
We were
like 10 years?
trying, still not happening. Okay, so we're going to state our question here is, okay, what do I want to know? Well, I want to know, how am I going to get to the lunch the fastest way possible? Okay? So, how do I think I'm going to make this happen? Well, I have to make a hypothesis. Do you know what hypothesis? Have you heard of that word?
I have.
Hypothesis?
Educated guess.
Beautiful.
You said it earlier.
Yeah, exactly. Okay? So I'm going to make some kind of guess on how I can get there the quickest. Okay? Again, teleportation, out of the question, can't do it. Okay? So if you were to make a guess, what would your hypothesis be to getting to lunch on time? What do you think?
Straight line. Shortest distance between 2 points.
Right,
Straight
absolutely.
line.
However, we have these things called stairwells and walls. We can't go through them. So we got to come up with basically a route.
I can't walk through the walls.
No, I know it's a little unfortunate.
I'm trying to be a ghost
What's
for the past few years. I would just really want to walk through the walls.
It's still not working, huh? What's that guy from Fantastic Four? He used to be able to do that.
Oh, I don't remember.
Okay, not either. But, you know.
I just keep thinking of Silver Surfer, but I don't think it's him.
Oh, yeah, but I don't think it's him either. All right, so we're going to state our hypothesis. Then we need to come up with this experiment. So if our question is, how can I utilize the whole lunch period? Okay, I need to come up with my experiment. Well, if I'm going to do some trials here, what do you think we're going to need?
Timer?
Timer, absolutely, because we need to know, well, how much seconds or minutes it's going to take me to get there, right? What else?
Maybe what time we get out of class.
Oh, yeah, so maybe like a bell schedule. So, you know, okay, I leave here at 9:50. Lunch starts at 9:55, which I know is the wrong time now that I said that out loud. Okay? And then we're going to have our procedure, which is our directions for the experiment. So for us, our experiment would be, okay, which is the fastest route, probably? I leave science class, I'm on the second floor, I have to take the stairwell, and I got to avoid all the people in the hallway.
So IMC stairwell or center stairwell?
Right, exactly. Okay, so that's our experiment. So we got our materials, we got our procedure, and then we're going to do the trials. So, for example, what we could do is leave our class, right as the bell rings, we press our timer, right? And maybe the first 3 days, I'm going to take the IMC stairwell and see how quickly I can get there. All right? So then I'm going to write down those times. Pretty simple, right?
Yep.
Okay? Then the next 3 days, I'm going to start my timer, and this time I'm going to take the central stairwell, all right, and write down those times. So we come up with our question, we came up with our hypothesis, we did our experiment.
Why do we do it 3 times?
Just because we want to have some room for error, we want to see, one time is not a good choice.
Okay, that sounds like a lot of work.
But it's science. That's what it's here for. We need to do more trials, better results, more accurate, more precise.
I get it.
Okay?
Accurate, precise.
Mm-hmm.
I
Very
just
good.
learned about that.
Yeah, that's right. Okay, so here's our results. Now this is my very sweet made-up data table I created. Okay, so if I took Route A, let's call that the IMC stairwell. Okay, my first day I did it and I got there in 1 minute and 2 seconds. Second day I got there in 1:01. Third day I got there in 1 minute. I clearly am getting quicker. Maybe why? I don't know. Maybe I know the route a little bit better. Maybe I can dodge and weave the students in the hallway.
Can we make another experiment for that in the future?
Oh, absolutely. Absolutely. And then Route B was the central stairwell. Well, you can see with Route B what happened there. If you look at our numbers.
Kind of random.
Yeah.
A little slower.
Yeah, definitely a little slower. So, for our results, it's just looking at our data, writing it all down. Then, when we get to the conclusion, that's where we look for the patterns, we look for the relationships, the trends. So, like, for us, our trend would be, well, we took stairwell A, which was IMC, and we got there really quick. We got there in right around 1 minute. So, based on our data, we would say, oh, Route A gets me there the quickest.
Awesome.
So, scientific method in a brief 5 steps, and it's a very easy
Route
example.
A, IMC stairwell, note to self.
Yeah, see, keep it in the back of your mind. So, any questions? We'll see you in class. Bye.